Hello mathematicians. Today's video is on functions, relations, domain, and range. So our objective for today is students will be able to distinguish between relations, functions, and find the domain and range. Take a second to copy this down, pause the video if you need to, so that you can get ready to take notes. Today we're going to talk about relations and functions, and so there's some vocabulary where we need to get out of the way. You'll notice that your notes for this is just a bunch of blank paper, so you're going to have to a lot of writing on today's video. Please make sure, I'm going to try and pause the video, pause when I'm speaking to give you enough time to copy it, but if I start talking again and you're still writing, make sure that you pause the video so that you can get all the information down before you start to listen to the explanation. So you are really actively listening as you hear explanations on what functions and relations are. So we need to get a little bit of vocabulary out of the way. And the first word that we want to talk about is the word relation. A relation. Now, a relation is just a relationship that we see in mathematics. And this relationship or this relation happens when there's a relationship between x and y represented by ordered pairs. Okay, so a relation is a relationship between x and y that's represented by ordered pairs. We've seen a lot of different kinds of relations. We've looked at graphs, we've looked at tables, right? So an example you might see of a relation is something like this. Let's say we had a graph. Here's our 0, 0 point. We have our graph labeled 1, 2, 3 on the x-axis. We have it labeled 1, 2, 3 on the y-axis. And then on that graph we have points. Point here, point here, point here, point here. Okay? These are linear points. We could connect these points and make a linear line. Okay, this is a relationship. Okay, this is a relation. We have a relationship going on between the x values and the y values on this graph. Another example of a relationship would be something that's represented in a table. So let's say we have a x and y table. And let's say we have 1, 4, 7 for our x's. And then for our y's, we have 2, 6, and 10. Right? There's a relationship going on right now between the x's and the y's, or the ordered pairs. Right? We could pull ordered pairs out of this. If our first one was 1, 2, our ordered pair would be 1, 2. Or ordered pair for the next set would be 4, 6. For the next set, 7, 10. So all of those things are ordered pairs, right? And they're represented by the relationship happening between x and y. That is what a relation is. The next vocabulary words we need to talk about are two words called the domain and the range. So let's start with the domain. Okay, the domain. Now these words are vocabulary words we use to describe the relationship that we see. Domain and range. So the domain of something is the x values in a relation. The domain are all of the x values in a relation. The range is the y values in a relation. The y values in a relation. So the domain and range are something that we use to describe what's happening in the relation, right? We might have a linear relation going on, and we might be able to describe, well, all of the x values fall between 1 and 5, and all of the y values of that relation fall between 2 and 4. So we use the domain and range to describe that. Instead of saying all the x values, we would say the domain falls between 1 and 4. The range falls between 2 and 4. So let's do a couple of examples of how you might identify the range and the domain. We might have to go onto a different slide, but remember, you're just continuing to take notes. So I'd write, all right, example 1. Here's your first example of something that has how you identify the domain and the range of something. All right, we're going to start out with just a basic table. Let's say we have an XY table. In that XY table, we have the numbers 1, 4, 8, and 4. And then for Y, we have 2, 6, 9, and 3. And let's say I asked you, identify the domain and range of this table. So what we would do is we'd look and say, okay, the domain, remember the domain is all of the x values, so that's going to be all of these values right here, all of these values here. Now, when we write them, it's best to write them in in numerical order from least to greatest. So I'm going to write, all right, I have 1, 4. I have 2 4s here, but I'm only going to write it once because although it repeats, it's the same number. So I have 1, 4, and 8. So my domain is 1, 4, and 8. My range, remember range is all of the y values. My range is going to be 2, 3, 6, and 9. 2, 3, 6, and 9. The only thing I did differently was I wrote them so that they were from least to greatest, right? But the range is all the y values. So we might say that the domain of this relation is 1, 4, and 8, and the range is 2, 3, 6, and 9. Let's go ahead and do another example of domain. So this would be example 2, right? Example 2. Let's say we had another graph, and let's say on that graph we had 0 right here, we had 1, 2, 3, and 4. Up here we had 1, 2, 3, and 4. And then we had points on this graph. So we had a point at here. We had a point at, let's say, about 2, 2. We had a point at 3, 3. A point at 3, 4. We had a point at 4, 4. And let's add another point right here. Okay. Now, this is a graph. When we look at this and find our domain and range, we can't just look at the table and write out the numbers. We're going to have to actually look at the graph and try to figure out what are the x values and what are the y values. So what I would do first is go through and identify what are the points on each of these, right? What are the coordinate point, or what is the ordered pair here? So like right here, let's say we have the coordinate point 1, 1, right? I'm going to say this is about 2, 1, right? Remember, I'm estimating. We drew this graph, right? We're just going to make things fall on whole numbers. We'd say this is about 2, 2. This is about 3, 3. This one's about 3, 4. And let's say this one is 4, 4. So we have all these ordered pairs. Now we can identify the domain and range. So the domain. I'm going to look at all of my points, and I'm going to look for what is the lowest x value that I see. So I'm looking, I have x values of 1, 2, 3, and 4. The domain, I'm going to say, starts with 1. Right? That's the lowest x value we have right here, the lowest one. Right? The next one I see is the domain 2. Now you'll notice that these 2 points right here, both of these points have a x value of 2. Remember, we're only going to write that once. They both have an x value of 2, but we only need to write it once. So a 2. And then I notice there's also 2 points that have an x value of 3 up here. I'm only going to write that once, 3. And then lastly, we have 1 point with an x value of 4. So I'm going to write 4. That's all of our domain. Let's then identify our range. So I'm going to look at all these points. Now I'm going to look at the y value in all these points and figure out what are the range of y values. So we have a 1 starting off. We actually have 2 1s, right? But I'm only going to write it once, 1 here and 1 here. Then I see a 2. We have a y value of 2 right here, right? So y value of 2, a range of 2. Then we see we have a y value of 3, a y value of 4. So in this instance, our domain and range actually ended up being the same. That's not always the case, right? Sometimes our domain and range will be different, sometimes they'll be the same. Remember, but we want to identify what it is so we can kind of start to describe the graph and the trends that are occurring on that graph. All right, let's go ahead and do one more. It's going to be example 3. Right, and this time, we're going to actually draw a graph that has a line on it. So I'm going to draw a graph. Right, we have 0 right here, and then we have 1, 2, 3, 1, 2, 3. I'm going to draw a line going up like this, right? On that line, we have points, let's say at 1, 1, 2, 2, and 3, 3. So we have points at 1, 1, 2, 2, and 3, 3. So when I'm looking at this line, you'll notice that there's a line, right? Our other 2 examples, we either had points in a table or points that were just on a graph. But in this instance, we have an actual line, right? We have something, the points are being connected. When our points are connected like that, when they're connected with a line, what that means is that not only do the actual points that we've labeled part of this relation, but every point in between, right? We could find a point that lies in between here, right? Somewhere where my arrow is pointing. And so we can't just write down the points that we see. We have to write down and include all of the points, right? Any point we might have from 0 all the way up to 3, 3. So we write the domain and range of points that have a line connecting them a little bit differently, right? And let's write a key point here. And the key point is this. When you have a graph with a line, when you have a graph with a line, now that could be a line that completes a full circle, that could be a line that completes a full shape, but when you have a graph with a line that connects points, you write the domain and range as a inequality. You write the domain and range as a inequality. So let's go ahead and let's do that now. Let's do the domain first. Remember, if you need to pause the video because you need to get something down, do that. So the domain, remember, is all of our x values. So I'm going to write an x for the middle part. And on a later unit, we talk about inequalities, but just a quick reminder, less than looks like this. This means less than. Greater than will look like this. Remember, the mouth always eats the bigger number. When we put a line underneath, it means less than or equal to. So less or equal. When we put a line underneath greater, it means greater or equal. So we're going to use those signs. Now, first, let's start with the bottom. We know, we can see on the graph that our line goes all the way to 0. So the lowest number that our x is going to be is 0. So I know that x needs to be less than or equal to 0. Now when we write this, we know that at the end it's going to be 0. Excuse me. 0. And then on the other side, we know that it needs to be no greater than 3. If we look up at the top, we can see that the highest x value on our line, just on our graph, is 3. So we might say, okay, the highest it needs to be is 3. Now to write our inequalities, remember we have to read from the x, reading from the x first. So we want it to be less than or equal to 3. So I'm going to say it has to be less than or equal to 3. 0, it needs to be greater than or equal to 0, so I'm going to put it this way. Remember, you read backwards, so we would read it like this. X is greater than or equal to 0, right? We read from the x, and here we would say x is less than or equal to 3. All right, let's go ahead and do our range as well. All right, we're going to start with a y this time because y is range. And I'm going to look, okay, what is the highest y value we have? We have 3. And what is the lowest y value we have? We have 0. Okay, remember, we want it to be read from the variable, so y is less than or equal to 3. And then y is going to be greater than or equal to 0. So the important key point to remember from this is that finding domain and range, you can look for the x and the y values, but make sure that if you have a graph that has lines connecting it, that you write as an inequality. Just to give you another quick example of something that might be like a graph, we're not going to actually find the domain and range, but let's say we had a circle, right? This is one line connecting the whole thing, so we would want to write it as a inequality. Write it as an inequality. Okay, goes to the key point. Let's say we had a shape that was like a polygon, right? That is a shape, there's a line, it's connecting the whole thing. We would want to write that as an inequality. Okay, let's now get into talking about functions. What is a function? So we've been talking about relations, right? And there's two sorts of relations that can happen. In all relations, there's domain and range. But in a relation, there's two things that can happen, right? The first kind of thing that can happen is that you can have a function, okay? We can have a relationship that is a function. We'll talk about what a function is in just a minute. The second thing is that you can have a relationship that is not a function. Not a function. And we'll talk about what that means in just a second. Basically, a relation is a special type of function where every domain has exactly one range. So let's write down that definition. So our definition of what makes something a function is going to be a special kind of relation in which every domain or x has one range value or y value. Right? It's a special type of relation in which every domain or x has one range. The easiest way to kind of show you this is to give you an example. So we're going to do our first example, and I'm going to give you quite a few. And let's make a table, okay? An x and a y table. And let's say I said, all right, in this table we have the numbers 75, 68, and 125. On this side I have 2, 2, and 3. What we mean is that every x value has to have one and only one y value. So you should look at your x's and say, okay, I have the x's 75, 68, and 125. Do each of these have one and only one y value? All right, 75 goes to 2, 68 goes to 2, 125 goes to 3. We basically want to think about every input having one and only one output, right? X is like our input and y is like our output. I would say that yes, this is a function because every x has one and only one y. We look, 75 only goes to 2. 68 only goes to 2. 125 only goes to 3. It's okay that the 2 repeats in the y because the x has only one y. The 68 has only one y. Another way of thinking about this is this. Think of x as a person, and I want you to write this down, and y as a place. Okay? And I want you to ask yourself, can person X be in 2 places at once? Right? Can person X be in 2 places at once? So for example, let's say that we were person 75. Right? We couldn't be in place 2 and 3. We could only be in place 2. Let's say we're person 68. We can only be in place 2. Now, can person 75 and person 68 both be in place 2? Yeah, you could have 2 people in one place. That's fine. But you can't have one person in 2 places. So if I asked you the question, is this a function? We would say, yes, this is a function because it has, every x has one and only one y. And let's actually write that in our notes. So yes, is a function. 1 x for every y. So yes, this is a function. All right, let's do a couple more examples and we're really going to flush them out and see what's happening. So, all right, let's do another example. And let's pretend like we had a table and we had, it was for sports. And the one side of the table said jersey number, like what was the kid's number on their sports jersey. And the other side of the table said age. So for our x value, we had their jersey number. And for our y value, we had their age, right? And I said, all right, in this table, we have jersey number 7, 6, 8, 5, 7. And then on this side, we had 10, 11, 1, 12, 13. All right, so there's our table. First thing I'd ask you is, all right, first, tell me what is the domain and the range of this relation. So on the side right now, I want you to write out what's the domain and what's the range. Pause the video and write out the domain and the range for this table. All right, you should have had the domain would have been 5, 6, 7, and 8. Okay, and we should have had a range. The range would have been 1, 10, 11, and 13. Remember, this is not a line graph, so we don't draw it with inequalities. We just write out the domain and the range. And the second thing I want you to answer for me is this a function? Is this a function? So looking at this table, does every x have one and only one y? Does every x have one and only one y? Think about that for a second. See if you notice anything wrong. We should have saw that we have 2 numbers here. We have that are causing us some issue. We have a 7 right here, and we have a 7 right here. Now, if these 7s both had the same range, the same y coordinate, or the same output, right? Those words are interchangeable. Output, y, range. That would be okay. But we have 2 different y ranges, or 2 different outputs, 10 and 13. I want you to think about this. If the x value is a person and the y value is the place, can person number 7 right here be in place number 10, and can that same person number 7 right here also be in place number 13? No. You can't have person 7 in both places, 10 and 13. They can't be in two places at once. So we would say this is not a function. This is not a function because the x value 7 has more than one y or range value. Right, so this is not a function. Okay, an easy key point that you can start to look for is just ask yourself, do the x's repeat? Do the x's repeat with different y's? Okay, do the x's repeat with different y's? If yes, not a function. If the answer is yes, then it's not a function. All right, let's say we have something like this. We have a table and it says, let's make two actually. We have x and y here, and then we're going to make something called a mapping diagram. Right? In this table, I'm going to have 7, 9, 3, 9, 6. And over here, I'm going to have 1, 2, 4, 2, 2. Let's do another example over here. Let's say we had 7, 9, 12, 15. I'm going to say that this 7 goes to 7. This 9 goes to -1. This 12 goes to 4. And this 15 is going to go 3. But it's also going to go to 4. I want you to pause the video for a second. We'll make this example 3 and this example 4. I want you to just look at these two and think, okay, are these two functions? And start to think why or why not. All right, let's first, for ourselves, let's just identify the domain and the range of each of these functions. So I'm just going to write D for domain, right, and R for range. I want you to, you might have an idea of, do I think this is a function or do I think it's not, right? I want you to, on your own, pause the video, write out what's the domain and what's the range of each of these functions. Right, we should have had a domain of 3, 6, 9, and, oops, sorry, 7 comes first, 7 and 9. And then our range should have been 1, 2, and 4. Right, over here we should have had a domain of 7, 9, 12, and 15. Over here our range should have been -1, 3, 4, and 7. Okay, now let's look. Do we think that these are our functions? Remember, every x value can have one and only one y value. So take a minute, come up with your final conclusion. What do we think? All right, number 3 is a function. So I'm going to put yes, a function. All right, and here's why. Every x has one and only one y. I know that right here we have the 9s repeating, but look, the 2 is what its y value is. So even though it repeats in the same place. Could person number 9 be in place 2? Yes. Person number 9 is the same person, and they're both in place 2. That's fine. Remember, it's okay if things repeat in the y. That's all right. That we have this many 2s. You can have people be in the same, more than one person can be in the same place. So yes, this is a function. Let's say every x has one y. Yes, this is a function because every x has one y. Let's take a look at example number 4. Right? we should have said, no, this is not a function. And here's why. We have 7 going to 7, 9 going to -1, 12 going to 4, and then 15 is going to 4 and 3. The person 15 cannot be in both places 4 and 3 at the same time. You can't have one input that gives you two different outputs. So this is not a function. Not a function. Because 15 has two y or range values. All right, we're going to do one more example, and this example is graphs actually. So let's do example, that was example, I think 3 and 4. So this will be 5 and 6. Okay, we're going to draw two graphs. So first one I want you to draw is a graph with a circle. And we're going to pick 4 points on that graph. Just let's say here, 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 and here. And we're just estimating, but I'm going to say, okay, this point is (4, 4). We're going to say this point down here is 4, -4. We're going to say this point over here is going to be -4, -4. And this point over here is going to be -4, 4. Alright, this first one, first thing I want you to do is write out what's the domain and what's the range of this graph. What's the domain and what's the range? Alright, for this, you have a graph. It has a line that's connecting all of the points. So we would want to write this as an inequality. So your domain should have been that your x is going to be less than or equal to 4 or greater than or equal to -4. Your range should have been that your y is less than or equal to 4 or greater than or equal to -4. Alright, now, is this a function? I want you to look and just think, is there any place where a point where your x values repeat? Look at the points. Is there any place where your x values repeat? Yes, you should have noticed I have 2 4s here, and one has a -4 and one has a +4, right? -4, +4. We can't have the x value 4 having two different y values. That won't work. It also happens over here. We both have -4 as an x, and then we have a +4 and a -4 as a y. That won't work. So this is not a function. So let's write down here, not a function. Because x values have more than one y value. X values have more than one y value. Now, we can also use something called the vertical line test to tell if something's a function on a graph. And we'll do example 6 on the next page. Let's write a quick key point about a vertical line test. So, if you don't want to look at the points on a graph, you can also look at a vertical line test. And here's what you do to do a vertical line test. First is you draw a vertical line. And you try to go through 2 points. If your if your line crosses graph 2 or more times, it is not a function. Okay, if your line crosses more than 2 times, it is not a function. So, for example, if I were to take this graph and draw a vertical line, my line would cross the graph here and here. Because it crosses in more than 2 places, this is not a function. All right, let's do one culminating example. I'm going to draw 2 things for you right now, a graph and a table, and I want you to do 2 things for me. I want you to write, what's the domain and range? And then I want you to tell me, is it a function? So, number 1, what's the domain and range? And number 2, is it a function? All right, here's your first. Let's take this table, x, y. I'm going to put 2, 4, 1, 3. Say 2, 4, 1, 1. Okay, tell me, is that a function? And what's the domain and range? And then second, let's take a graph. And I'm going to draw a triangle on it. Okay, we can say that this point right here is 4, -2. This point is, let's say, 2, 5. And we'll say this point is -4, 2. -2, excuse me. All right, tell me, what's the domain and range, and is it a function? All right, for this first example, our domain should have been 1, 2, 3, and 4. Our range should have been 1, 2, and 4. We should have said, yes, this is a function. Okay, every x has 1 y. For example 2, our domain should be written as an inequality because it is a graph that has points connected. So our x should have been less than or equal to 4. I'm sorry, less than or equal to 4, but greater than or equal to -4. And then our range should have been less than or equal to 5, but greater than or equal to -4. I would have said, no, this is not a function. And you could have said, well, there's places where the x's would be the same, right? For example, if we had a point right here and right here, they're going to have the same y value. I'm sorry, they're going to have the same x value but different y values. Okay, we also could have used the vertical line test. If we drew a place in a lot of parts of this triangle, we would have hit more than 1 point. So I'm going to say not a function. X values have more than 1 y value. So this is not a function. Alright, that is the end of our video. Make sure you write down any questions that you have. I know that this objective has a lot of vocabulary in it. So if you have any questions, please circle them, highlight them so we can talk about them when you get back to class.